experience. His area of expertise include virtualization, visual computing, high-performance computing, and deep learning. His expertise and core competencies lie in the design workflow of automotive sector. I request Mr. Sundara Ramalingam to please come up on stage and give a keynote address on the topic software-defined car, the road ahead.
Very happy to be here, and thanks to AutoNebula and Exhibitions India for having me here. This is an exciting topic, and I always get very thrilled and excited whenever I talk about this. Alright. See, I always believe that there are two types of innovation that happen in the world. One is what we call as the evolutionary innovation, and the second one is the revolutionary innovation. Any technology, forget cars, it could be mobile phone, it could be computers, it could be anything and everything that touches technology. A revolution happens and something new, which we have never even thought about or imagined, is born. And then it evolves. It becomes better and better over multiple decades. And then a revolution comes, and then it becomes something else which nobody would have even thought about. Typical example which all of us know is the mobile phones. And we are at the cusp of a revolution happening in the terms of technology. And all of us, this who are gathered here, this generation, is going to be the witness to that revolution that is going to happen. And then I'm sure the revolution will happen for the next 50 years. So, all the three previous speakers talked about connected cars and multiple things. So, my focus is going to be on what is the compute engine that enables this? What is happening inside the car that makes this possible? These are all mind-boggling, fascinating technology that we were talking about. But what is the enabler of this technology? That's what I'm going to talk about. And I can run 3 days course on this, but I've been given 15 minutes, and so I'll try to stick to the timing and try to make it as interesting and informative as possible. Can I have my presentation on the screen, please? I run the business for the manufacturing industry for the country, and with a lot of focus on automotive companies. All right. So, what's happening worldwide? Many automotive companies, a lot of automotive companies are opening research labs, new research labs, which have either existed or they are expanding the capabilities of the research lab in order to include the new thing that is happening, which is what we call the generic term that we use is the connected cars. And this has already reached unimaginable levels so far as the America, US is concerned, and then it is slowly spreading in other countries as well, other geographies as well. And you name any leading global car company, you will see that they have opened offices or expanded the capabilities of their existing office to include this technology, to work in this technology. So, in the beginning, this is what graphics used to look like, right? Very crude. I don't want to use the word crude. Very primitive, and it's fun. It looks like a kid's play video game. That's what it used to look like. But what has happened? Stunning visual effects have changed the way computer graphics has evolved over the past 4 or 5 years, right? It's a very short period of time in which this has happened. And now we are talking about not photorealistic. Photorealistic is something old, something which looks like a real one. That's old. What we're now talking about is what we call as the physically based rendering, wherein it not only looks realistic, it also behaves realistically. I repeat, it does not only look realistic, it also behaves as if the real one does. That is what is happening in the technology world today. And we at NVIDIA, we are pioneers in doing this work, and we have done a lot of work so far as connected cars and infotainment is concerned, and that's what I'm going to talk about. And we have more than 10 million connected cars powered by NVIDIA, which are already on the roads, running on the roads. Now, the future of the car, all our cars is going to be software defined. You can mark my words. Most of things what we do today is going to be driven by software in the future. So what do we do? What do we have today? What you see now is a central console, and the central console typically has entertainment systems, and you have your JS maps, and you have multiple controls, your air conditioning control, your windshield wiper, etc., many things, maybe your ignition key as well, all of that resides in the central console. And then you have the instrument control, which typically lies behind the steering wheel, and that has multiple meters that show you various parameters of the car. And so all this is going to be now software defined. And one thing that is sure to happen, or I would say is already happening now, is that the distinction between the center console and the digital instrument panel is vanishing. They are all merging together. Okay, and anything and everything is going to be at the touch of a button. Okay, everything, whatever you are doing today is going to be controlled by buttons and electronics. Okay, and whatever you are seeing on the screen, all these are going to be customizable. Okay, so you can decide what is going to be the top button. I mean, like you're customizing the desktop of your laptop today. I mean, you decide what is going to be your background, what is going to be the most used ones. You can design the look and feel of your car's infotainment panel accordingly. Okay, so this is how the software-defined car is going to look like. Now, whatever you are seeing on screen, nothing is mechanical. Be it the speedometer or the odometer or the fuel meter or name anything, any gauge, anything that runs, nothing is mechanical. Okay, everything is digital. Everything is software-driven. Okay, and the key is these things are intelligent. They are smart in the sense, as per the conditions of the road, and as per the conditions of the driver, and as per the requirements of the environment, they change. Okay. Now let's say that you are going too close to the side, the bank, and there's a danger that your car might slip over. The entire display in front of you is going to change, and is going to warn you with maybe a red flashlight or a beep beeps or whatever you want it to be, and tell you that hey, you are sleepy and you are going too much to the left or too much to your right. And that is the first level of automation we're talking about. The second level of automation is that the cars are becoming smarter, and the steering wheel will adjust, it will maneuver itself in order to avoid the collision to the side wall. Okay? That is what we are talking about today. And look at the middle panel, the instrument control. So it's going to change as per the needs of the driver or as per the needs of the road. And you are seeing terrains, or you are seeing the entire thing can light up, or you don't want to have digital instrument clusters, and it keeps on changing. I mean, as you cruise along the highway, this keeps on changing. I mean, what you see today could be this, but later on, due to the conditions of the car, you want the display to be bigger, or the car decides that, the smart car decides that it needs to be bigger. This is how it's going to change, like the illumination is going to change, and everything and anything is going to be software controlled. Okay. And this is what is happening as a technological development in the world today. And these are all high fidelity images. I don't know how many of you are familiar with the term 4K. 4K is the highest resolution which we have today, and it's like absolute. It's much beyond. I'm sure we all watch cricket on high definition television, and we all enjoy that experience of watching cricket on high definition television. This is one step beyond that. Okay, 4K. You need. I mean, I can never explain it over a mic. You have to experience it to understand how it feels like. And these are all going to be 4K screens. Okay, it's like 100% realistic. That is what we are talking about. And this is that is on the infotainment side. Okay, inside the car. Now we are moving to the next stage where we are talking about driverless cars. And as you can see, this is sort of a prototype. This is it's a picture what you are seeing on the screen, and this is how the internals of the car are going to look like in the near future. All right. Now, I mean, I don't want to spend too much time on this. I'm running short of time. I mean, I can spend 10 minutes explaining what is it you are seeing on this picture. But then, moving further on. Now, I talked about a driverless car, wherein you can see that the lone person sitting is facing away from the direction of the movement of the car. I mean, he is looking at the behind, and the car is moving in the other direction. That's what we are seeing in the picture today. Now, the biggest concern that everybody has is how safe it is. I'm not talking about the security part of it, which the previous speaker, the gentleman from touched upon. I'm slightly going away. How safe it is? See, because let us say, when we drive a car, all of us drive cars, don't we? When we drive a car, do we react to situations or do we predict situations? We predict actually. I mean, inadvertently, we don't realize that we are predicting. I'll give you an example. When it starts raining, without even thinking about it, you realize that the braking distance is going to be longer, and you start go slower. You don't, I mean, hey, it's raining, so braking distance will be shorter, so let me slow down the car. No, we don't think that way. I mean, our seventh sense ensures that we take the pressure off the accelerator. And then when taking the help from Manish, when a ball rolls on the road, you expect a child to follow it. And immediately, the moment you see a ball, you slow down, right? Okay, so that is what is happening. Now, and it's also self-driving is extremely hard because the world is complex, the situations could be complex, and it's totally unpredictable and it's hazardous. And we as human beings, our brain can predict. We don't react, we predict situations, and that is why when you're on the wheel, you feel safer than when somebody else is driving the car, aren't you? Okay. Now, how does the self-driving loop work? So we sense, the driver senses, and he maps it to the terrain, he perceives what needs to be done, and then he localizes it to what is just ahead of him, and then he plans. And this happens within half of a nanosecond. Otherwise, there's no point in doing all these things, right? Now, think how complex it would be to get this to be done by a machine. Okay, that is what we are talking about. And for that, a very, very interesting technology which is called as the deep learning technology has come into play. Now, this could be a new term, I don't know, maybe I'm wrong, it could be a new term to many of you, but I'm sure you all have heard of artificial intelligence and machine learning and all. So, deep learning is, I would say, a subset of a very, very niche part of machine learning, and we play a big, big role when it comes to deep learning. So, how does it work? The GPU, the graphics processing unit, is the workhorse of modern artificial intelligence and deep learning. So we create something called as a deep neural networks, DNN, wherein we don't program the computer to do what it needs to do. Today what do? We program the computer and tell the computer to do what it needs to do, but we train the computer by giving multiple scenarios, and we make the computer understand and predict what needs to be done so that the computer becomes smart enough to do what it needs to do. Alright? And that is done with the help of, now, when you do training, you need data to train, right? And how big is the data? The data has to be unimaginably big. And that is where the term big data comes into play. When it is big data, it is not big, it is like unimaginably big. Exabytes is what we are talking about. And so, what the computer does is, it goes through multiple layers of extraction, and each of the layers, whatever you are seeing on the screen, so long as they are, the deeper the layer, more will be the accuracy of the prediction, okay? And more will be the safety of the car that you are driving. And so that is where the deep neural network comes into play. And this is an extremely, extremely compute-intensive job, as you can imagine, because in order to ensure accuracy, you need to have a very, very big data, and all this data has to be computed real time, on time, and the decision has to be taken, and the decision has to be implemented. Okay, so you can imagine the mammoth, the size of the work that needs to go into coming out with a system like this. So this machine learning or the deep learning, it means the deep learning to make it more specific, has touched a lot of things other than the cars only. Something called as natural language processing. The term, the three words natural language processing, if I say in a different way, if I request Scott to say the same three words, he's going to tell you differently. So how does the computer understand? If you give a command, stop, I'm going to say stop, somebody else is going to say stop. So how does the computer understand? That's called natural language processing. Okay. And then emotion recognition. I mean, when one frowns, it has to recognize gesture recognition, body language analysis, localization, mapping, etc., etc. It's such an amazing science that we are witnessing now, and all these things are touched by what we call as deep learning, and the GPUs do use a lot of deep learning, and it even goes beyond security, like crowd behavior, face recognition. Like in a big studio, let us say there are two unwanted people who have bad intentions, who have entered that stadium, and they are going to in a cricket match. 20,000 people are there, and 2 people are like bad people who want to do bad things. So the security surveillance cameras can pinpoint them by comparing it to a big database and then alert the security. And behavior analysis, left items, people counting, etc., etc. So all this fall under the category of big data analytics and deep learning. And there's a supercomputer called the NVIDIA Drive PX2, which is the backbone again behind all these things. So as I mentioned, the objective, I'm more focused on telling you the technology that runs behind this. And it's a huge supercomputer, and it's as big as your credit card. And just to put things into perspective, it's equivalent to having, let's say, 150 Apple MacBooks in the trunk of your car. And the size, as I mentioned earlier, is the size of the credit card, your credit card. That's what we are talking about. And this goes into the ECU of your car and enables whatever I talked about earlier. Now, so what does it do? I mean, it can recognize objects. It can, even under poor visibility conditions. Look at this picture. I mean, these are actual pictures. So this is a very, very foggy day, and a lot of snow is falling, and the visibility is extremely low. And even under those conditions, it should be able to design. It should be able to capture the object, classify the object, and then decide what needs to be done as to the reaction of the car. And these are all not very esoteric things that we are talking about, our dream projects, etc. These are all adopted. I mean, these are all, as I mentioned earlier, about 10 million cars are running on the roads in developed countries, all these things. And in fact, a lot of big companies like BMW, like Volvo, worldwide on the car segment, they are using this, and this is what we are going to witness in the next 5 years or so. Now, we have a lot of automotive partners with whom we collaborate worldwide, and I mean, you can see a lot of names there on the screen. And we do a lot of research on this area, and our solutions are running on the roads through all these partners. Now, there are multiple things to learn. I mean, it could be the complexity of the scene, as you can see, or it could be a bully who is like the second picture you can see is a bully. I mean, he's on a bicycle and he's like, I mean, coming into your car, and you have to react. I mean, there's no way just because he's a bully you cannot run him over. I mean, you must brake. And when you brake, the car behind you has to know that you are braking, and he has to brake in order to avoid a collision. I mean, for no mistake of yours. So these are all conditions. These are all things to be learned by the computer. These are things to be taught to the computer. And imagine how difficult or how complex it could be. And then number 3, a school bus is approaching. A snowy condition, a hazardous condition, poor visibility, and the gestures of policeman. I mean, when the policeman raises his left hand, you have to understand that what he is saying. When he raises his right hand, you have to know what he is telling. And an ambulance, a very, very special scenario, which doesn't. I'm sorry. Excuse me. Sorry. And when an ambulance, it is a very special scenario, and you need to react to an ambulance. So these are all things that used to be learned, and an enormous engine, enormous computation happens here. So that is what I wanted to touch upon, given this short period of time. And the one message which I want to leave here is that, I mean, NVIDIA in India, we are not really a sales entity in India. We are more of a technology enabler in India, and we do a lot of work with all the global automotive players in India. And please do get in touch with us. We are also interested in nurturing the startup ecosystem here, and ensuring that the startup people who have gathered a lot here, they are given the right technology. We can hold them and ensure that they are coming up to speed. And we are very interested in developing an ecosystem and nurturing an ecosystem that will evolve and enable the technology that we are talking about today. And my coordinates are given on the screen. And please do meet up with me. I'm available today and the first half of tomorrow. And anybody who is interested to know more, who want to work with NVIDIA, it could be a startup or it could be an organization. I mean, let me know, and I will be very, very happy to explore how we can take it forward. Okay. Thanks again for listening, and thank you.